When we manipulate objects, we use not only the finger pad but also the sides and the hemispherical part at the end of the finger. This indicates that the tactile sensation should be presented over a wide area of the entire fingertip, not just the finger pad. To measure the tactile acuity at the fingertip, we used a contactor with a short linear edge. Tactile acuity was measured by pressing this contactor against the fingertip and having the participant respond to the direction. The experimenter pressed the contactor against one of the locations in this figure. All 4 types of contactors were used 10 times each at 16 locations. This resulted in a total of 640 randomly selected measurements. This shows a heat map of the average percentage of correct answers for each stimulus, location, longitudinal direction of the finger. This graph displays the 75% threshold at each location from the measurement results. The results indicate that the resolution is higher at the finger ends and lower at the finger pad. Contrary to previous studies highlighting a distinct change in tactile acuity at the finger end and finger pad, the present experiment showed that spatial acuity does not abruptly change at a specific boundary, but rather changes almost linearly. This shows a heat map of the average percentage of correct answers for each stimulus location, lateral direction of the finger. These graphs display the 75% threshold at each location from the measurement results. The threshold tended to decrease from the left and right ends of the finger towards the center. It is also important to emphasize that threshold values remain relatively constant between points D to F or points K to M. This indicates that the tactile acuity doesn't vary significantly from left to right at this specific region, where the finger pad exhibits some flatness.